Godot seems to be like more and more the perfect engine for making 2D games, and this week I've been playing around with 2D lights and normal maps for sprites in your scene, and let me tell you, it can really make your game shine and give it this kind of fake 3D look that looks really modern and really quite awesome without having to do too much really. Hey everyone, and welcome to another episode. I'm Ombarus, and welcome back to all those who already subscribe and know about my channel. For those who don't know, I'm kind of trying to make an in-between tutorial, but at the same time I don't want to give like simple examples like all the other channel out there. I'm trying to make it more real by using my own game I'm making as an example, which is a much more complex system. It's an actual game and not just some prototype or some demo. So you can go back in the previous episode and see the evolution of the game. But also I want to introduce some new subject every week, and I'm trying to use whatever I've been working on this week as the subject for the kind of tutorial I'm going to present. But during the week, at any one time, I could be working on 4 or 5 different things, so I always have to kind of choose which is going to be the more interesting or the more valuable for YouTube. And this week it's a bit tricky because I've been working a lot on the UI, the user experience, and working with some artists to try to help me make beautiful sprites and just in general revamp the look of my game. And so there's not that much stuff really interesting yet to show, but I've also been playing on the side with Godot's 2D lights and lighting system, and I thought that would be something really cool to show you guys. So let's just dig right in. The basic setup for lighting your 2D scene in Godot is pretty simple. What you just need to add is a light 2D node to any child of your scene that looks like some kind of light emitting source. And the reason you need to add it to some kind of visual is because the light 2D node itself doesn't have any visual, though it still needs a texture. And the reason for that is, if you look in 3D, lights are usually some kind of volume, and they have some fall-off attenuation, like a couple of parameters you can use to decide just how far the light is going to go. But in Godot, anyways, I don't know if it's like that in other games engine, but in Godot, you define all of these parameters using kind of a texture pattern that you attach to the light 2D node to get the fall off and all the settings for your light. So you could make a directional light using this, or you can make an ambient light, or you can make some kind of light that has a very small radius or a very big radius, any way you like using the texture. Now, once you've added a light 2D node in your scene, there's 2 more nodes that might be interesting to you to use in your scene. The first one is the light occluder 2D, and the second one is the canvas modulate. And the canvas modulate is a little bit special, but it helps you control the shadows of your scene, and I'll talk a little bit more about it later on. Now, just adding lights and shadows to your scene is already going to give it a pretty nice look. But if you really want to make your game shine, you should think about adding normal maps to your sprite. So, what are normal maps? They're just a texture that you add on top of your basic image for your sprite that will tell the shader, the renderer, how to treat lights on your surface. In 3D, they're usually used to add kind of like fake details, I would say, to your 3D meshes when you have low resolution mesh and you want some more grainy texture and stuff like that. But in 2D, it's even more important because a 2D object, a 2D sprite, is completely flat. There's absolutely no information about how the light should interact. But usually your sprite is supposed to represent some kind of image in 3D dimension, right? So if I have a planet, for example, well, my sprite is just a flat object, but the planet it's supposed to represent, it's a sphere, not a simple plane. Of course, if your game is using always the same view, for example a side-scroller or something, then you can kind of just assume that the light is coming, for example, from the top right, and just add the shading inside of the image of your sprite, and it'll look just fine. But for example, in my case, I'm generating the level dynamically, so I don't really know where the objects are going to be. And of course, the light source is the sun that I've positioned in the middle of my solar system. So depending on where the planet is, the light should light up the planet in different ways. So if I bake the shadows, it could kind of look weird. So the solution for that is to just add some normal maps to my object. And that's why Godot already comes built with a normal map for its sprite. When you select a sprite, you'll see you can already assign a texture and a normal map. There's already something built that will take the position of the light source and then use the normal value in the texture of your sprite to calculate how much it should brighten or darken the object on your scene. So let's have a look. First, let's take my planet and put it in the scene with the light, and let's not add any normal map. As you can see, it looks pretty flat. There's, if I rotate it or anything, it's just lit up the same way. It's still affected by lighting. So if I take it farther away, it's gonna get darkened. If I take it closer, it's gonna get brighter. But it's all uniform. It's all flat. So when I add the normal map next, as you can see, now there's beautiful shadows around the planet. And if I tweak the parameters of the light and the canvas modulate, you can see that I can control how much brighter the front facing of the planet is and how dark the back of the planet is. And now when I make the planet rotate, you can see that the shadows is staying the same, but the planet is rotating in a much more realistic, much more 3D way. But that's not the best part of normal mapping, because after all, lighting a sphere is pretty easy stuff. The best part is that you can encode any kind of 3D information you want inside the texture. So here I have another example of a ship I found on the internet that already came with some normal maps. And look at how boring it is without the normal map. It's just a flat ship. It has nothing special. But when I add the normal map, then it becomes something incredible. I can make it move around the sun, and then the lighting is gonna show and reveal some details inside the shadows. It'll just start to glow as you move the ship around. And this makes it so much more realistic, so much more clean and beautiful. I kind of like the feeling it gives, even though this at its base is still just a normal regular sprite. So what does a normal map looks like? Let's open one in Krita for a second. When you open, for example, the normal map of the ship I showed you before, you can see that it kind of looks like the ship itself, except the colors are all messed up. And the reason for that is that you can't really look at the normal map as a bunch of colors, because inside the shaders, what the engine is doing is actually taking the red, green, and blue component of the texture and converting it into a vector. So it's basically using the RGB component to create a 3D line in space. So for example, the red component on the texture would represent the left and right, and the green component would represent the front and the back, and then the blue component would be up and down. So this way, you can get a vector pointing anywhere in 3D space, even when you're in 2D. And then, what the shader does is that it takes this vector information from the sprite and multiply it by the direction the light is coming from. So if the two vectors are complete opposite, then you're going to get pure black because it's going to be multiplied by 0. But if you get something like 90 degrees, then you might get 50% black. And if you get something perfectly aligned, then you're going to get the full brightness. So it's basically emulating the orientation of the plane of the object you're looking at. So if I have a panel and I orient it in a way that the light is going to bounce off and come right in my eyes, then it's going to be very, very bright. But if I orient it like perpendicular to the light or something, then it's going to be very dark. And that's basically just what the normal mapping is doing. Now, handcrafting normal map is not so easy, and I've been looking at different ways you can do this. And it seems like the way most people do it is that they actually generate their sprite from a 3D model, and all the 3D modeling softwares out there usually support exporting your sprite or your object as a normal map. So they usually use that to generate both the sprite and the normal map, but it kind of give it like it's kind of too much. You can tell it's a 3D model that's been generated, I think. So that's definitely not for me. Another way that I've seen is that there's a couple of softwares out there that will take an already shaded sprite with the light from different directions, and then it's gonna calculate the difference between those image, and from that be able to generate a normal map. There's a couple of alternatives. I've seen something called Sprite Illuminator and also maybe something called Sprite D-Light, and I think there's a couple of others. I'm not sure there's actually some good one free, but I haven't tried these softwares yet, but it's something I keep in mind because it looks kind of interesting. Of course, the last way is to do it by hand, and if your sprites are not too big, it's actually quite feasible. Basically, what you do is that you load up, for example, in Krita, something called the normal sphere. So this is so that you can visualize each color, what they represent. The idea is that you need to color your sprite based on the direction each of the pixel would be facing in 3D. And to do that, you reference the normal sphere you have so that you can have an idea. So, okay, this pixel is like a panel facing to the left. So you go in your normal sphere and you choose a point on the left of the sphere that probably points around the same direction as the pixel on your sprite, and then you just color this pixel this color, and then you just go like this, color picking on the sphere the things that you think match the best on your sprite. It's a very lengthy process, and honestly, I've tried it and I didn't get so great results, and I think you probably want to use some limited amount. So if, for example, your game has a palette of 16 colors or something like that, then you probably don't want to use more than like maybe 32 or 30 or 40 different colors for your normal map, or it's probably going to look weird. So I'm looking for a way that I can like subdivide the normal sphere into color sections, but I haven't found a software that does that, so I might have to do it myself in maybe some Python script or something. It shouldn't be very hard to generate, I think. And if you've ever done that in your own game, and if you've been playing around with normal maps and stuff like that in Godot or Unity or anything, I'd be very, very interested to know about your experience in the comment section. I'd like to know what kind of issues you've encountered, how hard it was, if you have some tricks and softwares that I could use, because it's a technique I'm really interested in, but I don't know right now if it's worth all the effort I'd have to put in to make it work. But if you have experience, I'd very much like to hear about it. And that's it for this week. I hope you had a nice time, and if you learned something this week, consider subscribing, liking the video, and of course check out my Patreon. Consider supporting me, it really helps. And see you guys in my next episode. Bye!